The question is jump came, and what you're doing is you're starting at index 0. Each value is the maximum jump length from that spot, and you need to know whether that last index is reachable. So the key insight is that you never need to track which jumps you take, but only the furthest index reachable so far. So you sweep from left to right, and if you ever stand on an index beyond that frontier, you are stuck. And the time complexity of this code is O of n, and the space complexity will be O of 1. So I'll run you through this code line by line. Over here, you are declaring reach to be 0, so you set up your frontier. So before doing anything, the only place you're guaranteed to be is index 0 because you're standing over there. So that's the furthest reachable index, starts at 0. N is your last index, so the last index to check if it's reachable or not. For index jump in enumerate nums, what this gives you is the index and the jump, which is the number itself. So you're walking the array from left to right, and enumerate hands back the position and the value each time. And then you check if your index is greater than reach, you return false. So this is a failure check, and it runs before we use jump. So if I is beyond the frontier, no earlier index can throw you this far. You would have to be standing on an index you can't actually get to. So everything past I is even further away. So the last index is out of reach as well, and therefore you just give up immediately. And then you set reach to be max of itself, or index plus jump. So the index that you are on plus the jump, which means the number itself. Because we know that index I is reachable, so we extend the frontier. So from here you could land as far as I plus jump. So that competes with our current record. And then if I is greater than or equal to last, we just immediately return true. And if we reach the end of this, then we return true.